Hi everyone. Today we're going to talk about system design and responsibility architecture. In this video, we're going to take a look as well at three visual diagrams representing change in complexity, scale, and as well responsibility. So first we need to start with understanding that system design is a discipline of deciding where data lives, um, how it moves, and who controls it, and as well what boundaries should exist in place. So that means defining ownership, enforcement, and exposure as well. Every architectural decision shapes how a system behaves under stress, how it scales, and how it distributes accountability. And today we're going to emphasize not only about performance, but mostly governance. So a well-designed system diagram should make a structure visible. Each component today is going to represent a clear responsibility. Each arrow, an explicit data movement. Each database, cache, and integration is going to be visible. Trust boundaries are defined as well, which makes ownership identifiable. Very important, because when the structure is visible, risk becomes understandable, and with that, responsibility becomes enforceable. Clarity overall is the foundation of a secure and ethical system. So today's models that we're going to discuss, we're going to start first with a contained monolithic system. We'll progress to horizontally scaled system, and we're going to finish this with distributed microservices architecture. So as architecture evolves, complexity expands, and complexity changes responsibility. In the sense of our first scenario, which is a contained monolithic architecture, we can see that we have a movement from client directly to application to database. Now the control is concentrated, enforcement is centralized, and as well the data location is explicit. Auditing is also straightforward because the enforcement layer is unified. So responsibility is vertically integrated. This model does prioritize containment and clarity. Now, moving on to the second one, which would be horizontally scaled architecture. We have a system that obviously scales horizontally, and runtime instances do multiply. So we have in place a load balancer to distribute the traffic. Shared caching as well is introduced. And we do have centralized logging that aggregates the events. So currently the state begins to exist in multiple places. Therefore, coordination becomes essential. And of course, operational oversight does expand. Responsibility is still identifiable, but it now requires synchronization across components. Scaling does increase capability, but also governance requirements. In distributed architectures, services are isolated, so that leads us to our last diagram, which is distributed microservices architecture. And in here we can see that each service often is its own database. As well, we have communication becoming asynchronous, and as well message queues do introduce event-driven patterns. We have as well external APIs expanding the system boundaries, and as well analytics systems aggregate cross-service data. So in this case, ownership becomes distributed across teams. Data exists in multiple domains, and inter-service communication is increasing, therefore as well replication. And of course, the audit scope does expand as well. Architectural fragmentation directly increases the ethical surface area. So we have now more boundaries. We have, therefore, we do need more coordination, which means potential for failure in responsibility enforcement. Architecture reflects incentives. Data is an operational resource, and also data is an economic asset. Systems optimized for aggressive growth and monetization tend to increase data collection, data aggregation, and cross-service integration. This increases directly analytical power and increases exposure and complexity. Ethical design does not oppose profitability, but it strengthens longevity. And most importantly, trust compounds over time. So a system that prioritizes directly clarity, restraint, and accountability maintain durability under scale. Systems that expand complexity without governance do start and tend to accumulate structural debt. From a structural perspective, monoliths provide containment and centralized enforcement. Microservices provide modular flexibility and team autonomy. Both are valid architectural patterns. Every increase in distribution increases the responsibility surface area, and every additional service increases coordination requirements. So the question is, what are we optimizing for? Is it speed of growth? Is it operational clarity? Is it monetization depth or long-term trust? Because at the end of the day, architecture doesn't code those priorities. And in a sense, we can say that system design is a form of institutional design. It shapes how responsibility is distributed, how data is governed, and how systems behave under scale. Clarity is stability, containment is enforceability, and visibility is accountability. And as systems grow, ethical surface area grows with them as well. So designing for sustainability means designing for responsibility from the very beginning. And responsible architectures determine whether those systems endure or not. I hope that you found this interesting. I hope that you learned something new today. Thank you so much for listening, and take care.